Two and a Half Admins, episode 67. I'm Joe.
I'm Jim.
And I'm Allan.
And here we are again. And before we get started, your customary blog post plug, Allan, is demystifying OpenZFS 2.0.
Yeah, so this blog post just covers some of the things that changed with OpenZFS 2.0 and just as people are starting to upgrade from FreeBSD 12 to 13, what that's going to mean for them.
Right, well, link in the show notes as usual. Something you found a few weeks ago, Allan, was about how Google is extending the life of its servers and is going to save themselves $1.7 billion, at least on paper, as a result.
Yeah. So with Google's plan that they put in action back in January of 2021, they decided that, instead of recycling their hardware after 3 years or whatever, they'd add an extra year to the life of a server before they needed to replace it with newer hardware. And with this, their depreciation expenses, so basically they write down an amount of the server, of the cost of the server every year as the hardware's not worth as much as it was if we were to sell it now. And eventually after 3 or 4 years, depending on how they depreciate it, the hardware's worth nothing and then they throw it away and get new stuff. But by doing that, they on paper managed to save $1.7 billion by not replacing that hardware with newer stuff or just depreciating it more slowly. What I thought was most interesting about this is just, with the chip shortage going on, it can make sense to keep using those older servers longer. And just because we've not seen until much more recently the bigger jump in the performance of machines and servers, it's not, some of the newer platforms are just not quite there yet, that there's oftentimes no reason to replace your older server other than the fact that if it gets too old, it's starting to run out of warranty. But in the cloud where you're already set up to, the customer knows that they have to be running 2 instances in different availability zones or one of them could die at any time. It's not really the same problem if hardware dies versus, if you're a small shop with, 3 servers and if one of them dies, it's a big deal to you.
Yeah, I think the really interesting thing about this story is just kind of the spin of the story, honestly. The spin and the inherent lack of understanding of scale, basically, because Google has not done anything like impressive or groundbreaking or revolutionary. They've just decided, well, we'll give it an extra year before we chuck these servers in the bin. And if you want to save the same money Google did, you can save the same thing. Now, it's not going to be $1.7 billion in your case because you don't buy that many servers every 3 years to begin with. But that's really all this boils down to is Google just saying, you know what? We can stretch these things out another year. It'll be fine. I don't see any reason to doubt that $1.7 billion. The interesting thing there is it kind of flows in the other direction. When you say, okay, if they're delivering themselves a $1.7 billion revenue boost by not doing this, that gives you some idea of just how many servers they're buying, how frequently to begin with. That part's kind of the story as far as I'm concerned. I mean, we all know Google is huge and Google buys a lot of hardware, but man, that really just kind of draws a big red circle around it and brings your attention to it.
Well, yeah, in particular, it'd be like, okay, so the remaining value of the servers Google would have thrown away in 2021 because they were too old was $2.1 billion over 9 months. That's not even a whole year. So that means they already depreciated probably $2 billion off of them in each of the 2 years before this year. And they probably buy more servers every year. So this is also based on how many they bought 3 or 4 years ago. So just the amount of money they're spending on hardware is quite interesting. And you maybe start to see why it makes sense for them to look at building their own hardware now instead of just working with an ODM like Gigabyte and having them design, slightly customized motherboards. It's gotten to the point it's like, well, why don't we license and build our own ARM chip like we see Apple and Google or Amazon doing?
Well, I was going to ask you about power consumption because presumably when they chuck them away every 3 years, the ones that they replace them with are more efficient and therefore the power bill goes down.
Well, the power bill's not going to go down because you got to buy more of them than you had because your user base grew.
Yeah, more likely what they're going to do is replace a server that took up this much physical space with one that has more cores in that same space. So it probably uses the same amount of power, but you do get more out of that same physical space.
Yeah, the total power might not go down, but the power per user or whatever.
Sure, to some degree, although I don't think I would expect groundbreaking savings every 3 years, That's not going to be an enormous difference. Where you really see enormous power consumption differences is, where you've strung a server along for like a decade. Yeah, its replacement is probably going to eat a lot less power and, offer more performance. But 3 years is hardly a blip, depending on which 3 years you're talking about. If it was the 3 years during the long drought that AMD wasn't producing any new high performance processors and, it was pile driver or nothing, you're not going to notice it a bit. If it was the last 3 years, sure, you'll notice something there, but you're still talking about differences of typically like maybe 5 or 10% per server product cycle coming out.
Yeah, it's not as dramatic. And then, because they're adding so much more, their power bill is just always going up, and it's going to be hard to notice any savings from efficiency.
Now, if you chuck all your x86 stuff in the bin and replace everything with, a new custom ARM design, now you might be talking about some savings on your power bill.
Yeah, but some of these ARM servers can use just as much power. You just get more out of it. These 80-core boxes still use quite a lot of power, but you're getting 80 cores out of it, so it's a fair trade-off.
Yeah, they're not consuming a lot of power per unit of work compared to the x86 boxes they're replacing. I wouldn't really say per core is the best way to measure that, but if you want to talk about, like per spec int, or if you want to go into more consumery benchmarks, like, per Cinebench unit of score, then you'll see some pretty massive power savings.
Well, especially when you can customize your ARM core to have offload instructions for the specific things you're doing, whether that's AES crypto or SHA-256 or whatever.
Because what I was getting at is that, yes, they're probably using the same amount of power, but they've got a greater number of cores in the same physical box. And physical space is at a premium as well when it comes to investment in data centers.
So yeah, being able to fit a 2-socket, 128 core per socket machine in one U is beyond what you could even get from AMD right now as far as density. But, it's still, you have to be able to have enough power and cooling for it.
Which really, that's one of the key factors if you want to talk about the density also. It's not so much a case of, can I cram these electronics into a 1U box? It's a question of, even with like data center fluid cooling per rack, like, can I fit enough cooling channels to move enough fluid inside this box to wick away all the heat? When you're talking about, an ARM processor that does 2 or 3 times as much work and generates the same amount of heat as the x86 that it's replacing, well, now you're talking about being able to get more density because, again, really, it's the cooling that is the limiting factor on the density as well. You're right, Joe. Physical space is absolutely at a premium in the data center, but that's really the big thing that determines how much physical space do you have to consume is how much heat do you have to get off of this stuff.
Yeah, like if you look at the average 2U server, at least a third of it is just air. As dense as we pack things in there, there's a lot of air in there, and there has to be airflow or things break down, or, if you do liquid cooling or whatever. And then in my cases, it's storage. If I'm going to fit a 43.5-inch hard drives in something, then it takes up a physical amount of space. It doesn't really matter how much compute power it has there. It's just these drives are going to take that space.
Although, again, even there, if we're talking about Google stuff, I got to believe most of their storage has got to be solid state at this point. If you're Rust, there's a certain amount of physical space that you're going to have to consume that's just consumed by the medium. But once you start talking about solid state storage, you're right back again to what really determines the amount of space it's going to take is the cooling.
Yeah. And then enough NVMe, like PCIe lanes and so on.
I saw recently that Seagate has got at least some prototypes of spinning Rust drives with an NVMe interface. It seems like that is very much the future.
No. The main reason they're doing this is for people that buy a chassis that's only NVMe interfaces and want to be able to plug whatever type of drives they want into it, or to have, future-proof chassis.
Well, that's what I mean by the future. The future interface is clearly NVMe, but spinning Rust is not going to go away anytime soon.
I still think most of the drives they produce won't be NVMe interface. That'll be an option you can get. I expect it's only for like the hyperscaler use case or some specific use cases where it makes sense to just have one ubiquitous interface for everything. But I don't expect people's desktops to have NVMe interfaces for hard drives because the SATA port is just too easy.
Yeah, and NVMe is not all upside. There are definitely downsides to the NVMe interface. If you're not actually pushing the kind of throughput with the extremely low latency that NVMe is capable of, well, then NVMe kind of sucks. Like, it's a lot more difficult to build it as a hot swappable solution. because what raw NVMe really is just glomming your storage directly into your CPU via PCIe channel, which means that you have now exposed your entire system to stability problems that are generated, by the storage that in a more traditional SATA or SAS environment, you drop the drive and it's no big deal. Now, in the case of what you're talking about with Rust via NVMe, in a data center specifically, what you're really talking about is Rust over U2. And, the U.2 stuff has frequently there's a bridge in there that allows you to have that kind of separation from the system so that you can hot swap your storage when you need to. But again, this is all pretty weird edge case, high-end stuff and workarounds. I don't know. It's kind of like talking about Fred Flintstone shooting up with steroids before he gets into the Flintstone mobile is like the way of the future. No, it's not.
Okay, this episode is sponsored by Linode. Go to linode.com/25A and see why Linode has been voted the top infrastructure as a service provider by both G2 and TrustRadius. From their award-winning support offered 24/7, 365 to every level of user, to ease of use and setup, it's clear why developers have been trusting Linode for projects both big and small since 2003. Deploy your entire application stack with Linode's one-click app marketplace, or build it all from scratch and manage everything yourself with supported centralized tools like Terraform. Linode offers great price-to-performance value for all compute instances, including GPUs, as well as block storage, Kubernetes, and their upcoming bare metal release. Linode makes cloud computing fast, simple, and affordable, allowing you to focus on your projects, not your infrastructure. So go to linode.com/25A, create a free account with your Google or GitHub account or your email address, and you'll get $100 in credit. That's linode.com/25A. The Staples Center is being renamed the Crypto.com Arena, and this has ruffled a lot of feathers, and it feels like, Allan, you've been saying this for a long time. Crypto does not mean cryptocurrency, it means cryptography.
Yes, the crypto and cryptocurrency comes from cryptography, so you can't just short form it and expect people to be happy about it. Now, Crypto.com is a brand name and is a different issue, I suppose.
Yeah, if you stick the .com on the end, I'm fine with it.
Yes.
I mean, it's no dumber than the Staples Arena. I mean, it's not like they were selling paper clips in there or anything.
Yeah. Sadly, in Canada, every one of the stadiums is pretty much owned by a phone company or a bank. There is nobody else that can afford to own these things. Just like all of our newspapers and TV stations are owned by one of the telcos or one of the banks. But yes, there's just the hijacking of the meaning of words really annoys me.
I'm going to disagree with you, Allan, I'm afraid. I'm going to say to you that language is descriptive, not prescriptive, or I'm a descriptivist or whatever. Language changes.
Sure, but crypto only means cryptocurrency in this bubble of the neckbeards that are into cryptocurrency.
Right, and it means cryptography in the bubble of the neckbeards who are into cryptography.
Yeah, but here's the thing. If you're going to take the word crypto to just mean your stupid freaking butt coins, then we need a new word for crypto that actually still means what crypto means. And we don't have that.
The crypto in cryptocurrency still means cryptography. And so it's really annoying to see it abused that way.
And the real problem is that, this usage of it, crypto is just a shorthand for cryptocurrency. It undercuts that. And most of the people that are using it that way don't really have a great understanding of why crypto is crypto to begin with.
I get that, but I come back to the fact that language evolves, and it is on you as a cryptographer or that community to come up with a new word, because
no, it's not.
The word has changed meaning.
The crypto part of cryptography is Latin. Nobody comes up with new Latin words. It turns out they mean things and we don't just change them.
And no, it's not on cryptographers to come up with a new word for crypto. That would be like if Allan and I started saying, I don't know, Joe means dog kicker. And now it's on you to come up with a new name for yourself because we decided that your name means somebody who kicks dogs. Like, no, that's not how that works. That's not how any of this works.
That is kind of how it works in the playground, though, isn't it?
Whatever, dog kicker. So what's your new name, dog kicker?
Right, well, I'm going to be Dave from now on then, it seems.
Oh, you don't want to know about Dave.
But, this isn't the case where we see, where facial tissue became Kleenex and it was one brand name kind of became synonymous with the concept. That's not really what's going on here. It's just abuse of the term.
I can't help but feel that you are both old men yelling at a cloud here.
I'm not yelling at the cloud. I'm yelling at a bunch of dumbass crypto bros. Come at me.
Like, this is a root word that's used in hundreds of words, and we can't just change the meaning of the root because of this one weird use case in this one weird bubble.
Exactly. It's not just taking over one word. It's taking over a freaking Latin prefix that is a part of a vast swath of terms.
I get that.
Do you?
I do get it. Yes, but I just keep coming back to the fact that language evolves and you cannot stop it evolving. There's nothing you can do, right? In my country, one day, a bunch of people decided that H is pronounced Haitch with an H at the beginning. And it isn't, but that didn't stop them saying it. And now more people say Haitch than H. And now I am wrong because that's how language works. Things changed. I didn't change with them. And now I'm wrong for saying H.
But that's not the only way things change. Things also change when people decide, you know what? That was stupid and we're not going to do that. Like, for example, how many people do you think over here on my side of the pond say Haitch? None of them. Well, it's not that we don't know that you do it. It's that we all said that sucks and we're not gonna.
Right. And so therefore you say H. We say H, or most people do. I don't, and I never will, hopefully, because it's like fingernails on a chalkboard when I hear someone say it. But that doesn't change the fact that the word has changed its meaning and crypto has changed meaning in technical terms to mean cryptocurrency.
It hasn't changed meaning.
What you're arguing for, Joe, is the lowest common denominator always winning, and I refuse to accept your argument. Just because somebody makes a stupid decision with language doesn't mean that I have to abide by it.
Right. No, but if enough people follow them, then you do.
Sure, but I think your barometer for enough people is what's broken here. It's like, because of the bubble that is kind of the social media sphere that we happen to be in, it seems like this majority of people think crypto means cryptocurrency. But if you actually look at a wider swath of people, it doesn't.
Whether even you're talking about a wider swath of technical people or non-technical people, either way, no, most people don't think that's what crypto means. The people who I know who actually use crypto directly as an unironic shorthand for cryptocurrency, I don't know, 1% of the people I know, maybe. And, it's like the dudes at the local PC shop that are doing GPU mining on the spare store computers, I don't just expect that, like, I'm going to go talk to some normal person on the street and be like, hey, man, how's your crypto doing? And, like, have them immediately be like, oh, I love Ethereum, but Bitcoin sucks. No, they're going to be like, what?
Now, I'm going to propose a thought experiment. Say you got 10,000 people and you surveyed them all and you said to them, here's a bunch of computer words. What does it mean? And you had like RAM, hard disk, crypto, ZFS, whatever, right? Most of those people would probably not have an answer for what crypto was. But I would argue that of the normal people on the street, more of them would say cryptocurrency than cryptography.
I think you're wrong. Because of the Cold War and shit, most people are familiar with what cryptography means.
Joe, do you remember the 1990s?
Vaguely.
Almost everybody I encountered in the 1990s thought that the hard drive was the entire case of your computer and everything in it.
Yes.
Do we call computers hard drives now? No, we don't, because that was a mistake, and it was reductive and stupid, and we as a society did not adopt it.
They call it what they call it because funny money turns out not to sell it very well.
Even now, most people think the CPU is the entire freaking computer. They think you have a monitor and a CPU. If they even know that the monitor is something different, they think you got a monitor and a CPU.
Oh, yeah.
The vast majority of people have no freaking idea what a central processing unit is, what it looks like, anything about it. But I don't call my desktop machine a CPU.
But if enough people had, then you should.
Again, no.
No. The whole point is you fight back to prevent the bad thing from happening. Bad things only happen because good people sat by and did nothing about it.
All that is necessary for the triumph of evil is for good people to do nothing.
Well, that's why I continue to say H.
And that's why Allan and I are vigorously slapping you all throughout this episode.
Yeah. Okay, this episode is sponsored by CBT Nuggets. training for IT professionals or anyone looking to build IT skills. Go to cbtnuggets.com/25admins and sign up for a 7-day free trial. The on-demand virtual labs mean you can build practical experience with the commands, config, scripts, and everything you need to get the most out of each course. Another standout feature is the accountability coaching service, available to all learners with a subscription, which gives you access to a real person who will help you craft a personalized learning plan and set goals, and will check in with you to keep you accountable. So start your free 7-day trial today at cbtnuggets.com/25admins. It includes unlimited access to all course materials, including virtual labs. That's cbtnuggets.com/25admins. Let's do some free consulting then. But first, just a quick thank you to everyone who supports us with PayPal and Patreon. We really do appreciate that. You can go to 2.5admins.com/support to learn more about it. And remember, for $5 or more per month on Patreon, you can get an advert-free RSS feed. And if you want to send in your questions or feedback, show@2.5admins.com. Send us an email. No question too dumb. Okay, Jim writes in, not that one. I have an existing WireGuard deployment at work, and it puts all our other VPN solutions to shame. My problem is that some departments have compliance requirements which prevent any non-multi-factor remote access solution from consideration. Do you have any experience with multi-factor auth and WireGuard for environments where it is a requirement?
Not inside WireGuard specifically. My understanding is that Tailscale can do that, but basically the better approach, I think, is rather than tying the multi-factor auth to WireGuard itself, tie it to the firewall behind it. It doesn't have to be anything to do with WireGuard. Like, I'm pretty sure Palo Alto firewalls can integrate with Duo for MFA. So whatever your MFA solution is, in theory, you should probably at this point where you're talking about, multiple departments with the MFA requirements, if they're not already implementing that at the firewall level, they really should be. And if they are, then, well, it doesn't matter if you can connect over WireGuard or not, because those packets don't go anywhere unless you've MFA'd to the firewall.
Is the problem not, though, that when it comes to compliance, it's not necessarily about common sense. It's about box checking, and you can't check the box for WireGuard.
Well, it is about box checking. The box that you're checking is remote access, and you have no remote access if you can't get through the firewall, so box checked. A large part of the box checking that you're talking about is having the technical knowledge and the confidence to simply state, yes, I have checked that box.
I think the captive portal has, once you're inside the VPN, has a bunch of advantages, including just centralizing the configuration and the management of all the two-factor stuff on the sysadmin's control zone inside the VPN. And it means that you don't have the complication of, we need the client that supports 2FA to work on all these different devices that WireGuard is available on. Instead, you connect to the VPN and then you have to pull up the browser and do the two-factor authentication, whether that's with your phone, with Duo and the callback or whatever, before you can access anything. And it means it's more compatible and you have more control.
Yeah, so basically the way this works is there's a default deny rule. And if you want to turn that default deny rule off, you got to pass the MFA. Until then, your packets go nowhere because, again, default deny. That includes all network level attacks because, again, we're not talking about just saying, you've already got MFA on the individual services, so that's fine. That would leave a hole that you could argue with because you say, yeah, but now you have network level access that you didn't before. But if the MFA is on the firewall, you do not get any network level access simply by having established your WireGuard tunnel. There's another step required. That's the whole thing multi-factor authentication is supposed to be.
And the other advantage of this means you can have the same multi-factor authentication for your Wi-Fi or your guest network or a second VPN product that you're still using for some reason. It means you can have all of your different multi-factor controlled by this one system and it, single sign-on. That's what people really want.
Write your own SAML app if necessary.
It just gives you more control and more flexibility, and it solves the problem nicely. And it means that you'll have more logs about what happened with the 2FA on your side, rather than the logs being on people's cell phones or whatever device they use to connect to the VPN. So it gives you a better audit trail as well.
Okay, Christian says, how do you test network quality? What are the parameters that you would include beside latency and speed? Is there some tool or container that I can run on my network to discover any issues like disconnects, DNS problems, jitter, IPv4 versus IPv6, etc.? I've been trying to find some information on this, but most of the tools only do speed tests and cannot check quality over time.
Turns out I wrote a tool specifically for that called NetBurn. What NetBurn does is it expects you to stand up an HTTP server, and then NetBurn connects to that HTTP server with a very configurable number of clients, expected throughput, in terms of page fetches per second, yada, yada, yada. And you can control how large the file is that it's fetching on the other side. You can also introduce jitter, just about anything you can think of. Now, this was specifically, I designed this to test Wi-Fi networks because Wi-Fi sucks. For the most part, on an all-wired infrastructure, you don't really need something like WireGuard because the throughput will tell you pretty much everything that you need to know about the actual infrastructure layers of it. And we're not talking about your application on the other end, but the actual infrastructure. If it's wired, modern, it really doesn't care what you're throwing at it. But when you get into Wi-Fi, it's a whole different story. And you find that in particular, the fact that Wi-Fi is a single device gets to talk at a time for the whole broadcast and collision domain, that means that your latency for any given packet is highly variable. And because of that large variability, that means that an every once in a while, but it keeps happening, kind of issue. Like maybe you ping a server and 90% of your pings come back in 2 milliseconds, but the other pings come back in 500 milliseconds. Well, you're not really going to see that big of an impact on a simple throughput test. But if you have a more complex test like what NetBurn will do, I'll set it up with multiple concurrent clients, and you measure the application latency in terms of, let's say you've got 16 concurrent sessions going, and each one of those concurrent sessions is fetching a large object over HTTP. And you measure the latency in terms of when the slowest return comes back from any one of those, 16 clients. Well, now you've amplified the issue, the relatively transient issue of every once in a while a packet goes rogue, into something that you can actually see in your results. Whereas in a simple speed test, it just completely gets lost in the mix.
Yeah, and I think part of what Jim is talking about there as well is there's kind of two different types of measuring the quality of your network. There's, let's do a test right now and look at, the throughput, the latency, the jitter, the standard deviation in the response time, the amount of packet loss, and so on. And then there's, I'm going to monitor my connection 24 hours a day and look at it on a much larger time scale. And, I'm not going to be trying to download something constantly for all day, every day for the month, but I want to see when there are problems.
And, when you're talking about looking at these kind of quality of service type issues, I think another thing that it's important to point out that most people don't quite get is that the best test is usually not one that loads the infrastructure entirely 100% to capacity. It's a test that models the way you actually use it as closely as it can. Like, for example, recently in doing some storage performance testing, two different systems looked very similar when I just did a completely unthrottled FIO run across them and, got the maximum throughput that I could, even when looking at the latency numbers for that FIO test that was completely saturating the medium. The two different systems didn't look very different. However, when I throttled that FIO run down to about 50% of the throughput capacity of the storage medium, which is much more in tune with how storage is actually used day to day, now you're looking at differences of up to 2 orders of magnitude between these two systems, because while it turns out they both ran about the same amount of crap when you absolutely torture tested them within an inch of their lives, when you ran them the way that you would normally operate those systems, one of them was very clearly more dependable, more reliable, got your answers back to you more quickly than the other one did.
One thing that I have at my house, I think there's a VM version or something you can get, but RIPE, R-I-P-E, the European Authority for IP Addresses, has this system called Atlas, and they send out these little probes, which are like reflashed old, like Realtek Wi-Fi router USB-powered majiggers. And their idea is to put these all over the world and just measure the quality of people's internet connections. And so it just sends out a couple of pings and checks various things and sees how your IPv4 and IPv6 work and so on. And they can be a cool way to do it. And they give you all the stats from yours. But for having one, you also earn credits where you can do pings and trace routes and stuff from other people's appliance as well. So by having one, you earn credits to be able to measure things from other places, which can be useful depending on what you're doing as well.
So your tool, Jim, Netburn, is that the 700 lines of Perl that I just found on GitHub?
Sounds about right.
Okay, well, link in the show notes.
In the show notes, I also threw up a link for Tom Jones, who's used to be a network researcher at a university, wrote us a great article about troubleshooting and just understanding network performance. And it talks a lot about how some of this stuff applies as well.
Yeah, it's not unusual for him to write great articles for you, is it?
Nope.
Right, well, we better get out of here then. Remember, show@2.5admins.com if you want to send in your feedback or questions for Jim and Allan. And remember, no question is too dumb. You can find me on Twitter @Joe Ressington.
I'm at JRSSNet.
And I'm at Allan Jude.
We'll see you next week.